This is Jenny Kunkel, and in this video we are going to cover the physical design for our previously determined logical model. And at this point, with our physical design, we can determine storage requirements. We're going to not necessarily go through the practice of doing that. For SQL Server, we don't need storage requirements. For Oracle, we would. That probably is a little bit beyond the scope of what we're trying to accomplish as developers. So we're going to just kind of like hold off on creating an Oracle database, but we will go through the practice of creating an SQL Server. We'll just go ahead and add some tables and sequences and indexes and foreign key constraints, etc., to an existing Oracle database. So we can go through the practice of how we can create some of those items, but not go through the more difficult practice of defining the database. Typically, you're going to have a database administrator who's going to take care of that. And as a programmer, you're not going to have to go through that practice. We're also going to go through and choose the data types, and that's going to be based off of whichever database that we're using. We're going to determine constraints, whether we have any not null fields that are required, or whether we have some check constraints that we want to make sure that certain values are entered. We can do that within the database itself. We can also take a look at some DBMS specific features like sequences or identity columns. And then there are also things like collating sequences, which can be used and defined on a column or even at the database level for Oracle. And that's going to help with trying to do sorting. And also when you're trying to compare things, it's going to use whatever the language type feature is that you're trying to use for those collating sequences. We're not really going to go through and apply any of those, but those are some of the things that you would have to consider for a DBMS specific feature. And then also indexes for searching. In a lot of cases, when you're doing your initial design, you're not necessarily focusing 100% yet on the searching criteria. You're just trying to get the database set up. And in a lot of cases, after you continue to work through the application development, that's when you're fine-tuning things, and that's where you're going through the practice of creating indexes. But we'll go through creating an index just for the heck of it so that we can see how to do that. With our data definition design, so this is data definition language that we're going to be creating. And this is going to allow us to create databases, tables, primary keys, foreign keys, constraints, and indexes as well. With creating a database, the basic syntax is going to be create database, and then you're going to specify the database name. You can also remove a database by doing a drop of the database, and you just specify drop database and then the database name. You can also do a drop if exists and use the database name if you're using SQL Server or you're using Oracle 23C. It wasn't introduced until that point in time. Now, what does this look like if we're coming into SQL Server? I have a SQL Server instance up, and let's go ahead and for our prior example, we're going to create a new database called academic records. So we're going to go ahead and create a new query. And in this case, we're going to go ahead and create the database. We call this academic records. And we're going to have to start using goes because we're going to be doing different type of create objects. And we need to have essentially a batch process. And this is going to be where we're going to create the database, and that's a batch. And then if we want to go ahead and switch to that database, then we can use our use statement and then switch over after we create it so that anything that we do after that is going to be reflected there. So if we go ahead and execute this, we should see that we've created a new instance of a database. If we go ahead and do a refresh, give it a moment or two, we should see that now we have our academic records. It's just that easy. Now, of course, we have the ability to go through the SQL Server management tool and do a lot of this stuff using some of the features that are built in. But think about from the standpoint of we're building a script for our test environment to run, and then we're going to reuse the script when we go to production. Having it as a script allows us to do that without having to reproduce all of the clicks that we're going through SQL Server and trying to get everything set up, and that would be potentially we might lose something. So we've already created our database. We're not going to drop it, but if we did, we would need to go ahead and switch to a different database, because if we don't, then it's going to be in use and it will not allow us to drop it. Once we have switched to another database, we could go ahead and do a drop database if exists, and then I could do academic records. And if I go ahead and just execute all this, we see that it's processed. And if I go back and do a refresh here, we see that it's gone. I'm going to go ahead and just go back and add it back and just comment out this processing down here below. Now going back to the slide deck, we've added our database. Now it's time to go ahead and create all of the tables that we had for our student and course and teacher and student course. And in this case, we have a basic statement for creating a table. And this is essentially going to be create table with the table name. And then we're going to provide our first column, and then we need to specify the data type and then the constraints. And so the constraints are going to be whether it's not null, meaning that it's a required field, if it is using an identity, if it's a primary key, if it's unique, if it is something where we're going to give it a default value. All of those would be things that we would use in the constraints. And if we look at the next slide, we have a couple of options here. Now this is for determining a primary key. When we do a create table with student, the student ID is going to be integer, and this is of course going to be in SQL Server. It's going to be using an identity, not null. Primary key, I can define the primary key on the same line, or I can go ahead and set up a constraint. Now the nice thing with a constraint is you can give it a user-defined name. If you use it on the line, it's going to generate something for you. And sometimes it generates something that you can understand what it is, and sometimes it's something that's a little esoteric, especially in the case of Oracle, and you have no idea what it's actually generating. So in a lot of cases, it's a lot better to actually go through the practice of setting up a named constraint, so you can always name it in such a manner that you understand what its purpose is. In this case, you would just say constraint with the primary key name that you want it to name, then the primary key, and then clustered. If we look at it from the Oracle perspective, we see that we have a before 12c when the identity did not exist, and then the after 12c with identity. Using the identity makes things very simple for us. Typically before 12c introduced the identity, we would have to create a sequence, and then when we are inserting data into the table, we would have to use that sequence to get a number to insert into the table. And we are going to use a sequence for the teacher ID when we get to the teacher, but for our primary keys for our student ID, we are going to use the identity. So this is going to be the 12c for the Oracle, and also when we are doing it for our SQL Server, we're going to use the identity for everything except for the teacher, because we want to do it in both places, because we have that feature where we can use the sequence for inserting a value in a SQL Server table as well, so we want to illustrate that. So in this case, we can see that the identity is generated just a little bit different, and we also notice that on our constraint, we do not have that clustered. So essentially everything else is the same except before the list of fields, because we can have more than one. We'll see that in the next example. This is going to be essentially missing that clustered. If we go back, we can see that clustered, and we do not have it over here on the Oracle side. If we switch to SQL Server, we're going to go ahead and add the data definition language to create our student and our course. And we are also going to go ahead and add the drop statements. I like to have the drop statements prior to the tables. This makes my script rerunnable because I can just go ahead and drop everything and then restart. I'm also going to go ahead and comment out the create database and the go statement. I can go ahead and just kind of go through, and if I would execute this bit here through this bit, it's going to go ahead and create my tables for me. And let's go ahead and refresh, and then we'll take a look at what's in the script here. So now we see those tables there. We have our student ID, it's type integer. Using the identity, it's a not null field. We have our student name, we've defined it as varchar 50, not null. We have our constraint, which we are naming. The primary key is student ID. Similarly, we have the course with the course ID. Now in this case, we have an explicit 6-character value, so we're using the char instead of trying to use an identity on that field. We have the course name that's 50 with varchar. Since this is going to be a hard fix 6, we want to keep it as char, not as varchar, because we don't want the overhead. We have the course ID as our primary key. Now we can go to Oracle and go through the same practice. If we create our table, we're just going to do it in our CO. I can go ahead and execute these. They're going to look similar, but a little bit different. So we have our identity here. We have our char here. Essentially, we're using varchar 2 instead of varchar, and we have our primary key without that clustered. And I can go ahead and execute this, and I have my tables that should be created. If I go ahead and refresh here, I should see them pop in here. There's my students and my courses as above. I want to go ahead and add in my drop statements. Now again, the drop, if not exist, does not exist in the 22C, which is what we're using. So we have to go ahead and just use the drop table. So that means that if we try to run it without the table being defined, we're going to get a lot of errors. But I could go ahead and rerun the script now because I have those two tables created. So going back to our slide, we also have the ability to use a concatenated key, and this is going to be student ID, course ID, and teacher ID. This is for SQL Server. We can tell that because of the clustered. When we have multiple fields, the only way that we can actually do that is through a constraint. We can't define it on each of the lines of the actual fields itself. Doesn't work that way. And we typically try to arrange the fields how we might query them for the best performance. If we look at our Oracle instance, we have our student ID, course ID, and teacher ID, similar to what we had before. Again, just missing that clustered that we saw on Oracle. We're not going to go ahead and define this table yet because we have more to do on this. If we go ahead and take a look at our teacher table, and this is going to be where we want to add a unique constraint on our teacher email, because we don't want duplicate values being added to the database. So not only can we do the not null that makes it so that we have to have a value before to allow it to store, if we try to insert something that has the same teacher email value, then it's going to fail as well. So that's another way that we can ensure that we don't have garbage data going into our table. So we have the ability to define it on the actual field itself, or we can name that constraint as well. So this is for SQL Server. If we look at it in Oracle, it's pretty much the exact same way. So let's go ahead and let's flip over and notice that I'm not using an identity on the teacher ID in either database because we're going to be using a sequence. And we'll take a look at how we can create that in just a little bit. So if I go back to SQL Server, I'm going to copy in my teacher definition here, paste it in, and I can execute that portion, and I can go up and add my teacher drop clause as well, put it at the very top. Now, in some cases, when we get to our student course, it does matter the order of how we put our drop statements, because with our foreign keys, we have a dependency on the parent table, so we have to delete and drop the table that has those foreign key dependencies before we actually do the parent tables themselves. So we'll see that placement when we put in our student course. Now, if we switch over to Oracle, because we should see that we already have our table, let's go ahead and refresh and expand the tables. We have our teacher table there. If we go to Oracle and add in our table there as well, I can go ahead and execute this. And then I can go ahead and add my drop statement as well. And again, notice that they're plural for our tables in Oracle. That's more of the tendency to do that in Oracle, and singular in SQL Server. We also have different fields. From the naming convention, we use snake case in Oracle and not. We use titled case in SQL Server. Refresh it to get it here so that I can see that I have my teachers at this point. So going back, we've added that unique constraint. We can also add check constraints. That's something else that if we have either a list of things that we want to check to see if it's in a particular list of values. Now in this case, it'll let us store null or A, B, C, D, or F. Now if it's our intention not to store null, this is not going to actually work. We can also specify that if a value gets stored, if we were looking for a grade and it was a numeric value, I could do something where grade is greater than 0 and less than or equal to 100. I can put in those types of checks as well. So that gives us a little bit of additional capability to do validation before it enters into the database with our check constraints. We're still not going to do our student course because we have our foreign key constraints that we want to look at as well. But notice that we can do a check, and we will be adding that later. And then finally, for Oracle, so that's SQL Server. Oracle, we have the same capabilities. It looks and works exactly the same way. And now if we go to our foreign keys, this is where we have foreign key constraints, and we essentially have a field here that we need to reference in the parent table. And based off of the behavior in the parent table, we want it to potentially do something in the student table. For instance, if we deleted a student and we wanted everything to be deleted at the point from every other table, then we could do that using an additional qualifier here after the references student with a delete cascade option. In this example, we're not going to do any delete cascades. In the next example that we go through, we will actually put a delete cascade condition on one of our foreign key constraints and take a look at what happens when we're trying to delete something from the parent table. So we have our foreign key that is using the student ID. Now again, we don't have to have these fields named the exact same thing if the intent of the data is the same. Depends on how well you're defining your tables and structures. Typically, you like to have the same type of identity for the fields, but in some cases when you purchase software, that's not the case. And things are a little bit dirtier with the design there. So we have the foreign key referencing the student table on the student ID field. So we have multiple conditions for foreign keys here. Pretty much the same way with our Oracle database that we have our foreign key associations there as well. SQL Server, and I'm going to add in the student course and execute that. So it has my check constraint, and I am using the check constraint where I can actually name it. It has my foreign key constraints as well. And I have gone ahead and created that. I should be able to refresh and see my table if I expand the tables, and I have that student course. Again, now because I have added that, I want to add my drop statement. And again, the placement has to go before the other tables. So these are the parent tables. I have foreign keys basically from the student course pointing to the student, to the course, and to the teacher. And I need to remove these before I can actually get rid of these tables. So we'll not allow that to be processed. So at this point, we're going to switch over to Oracle and run the statement there as well. Again, I pretty much have everything defined essentially the same way. If I look at it here, we have our constraint for our check, essentially defined with a named constraint. We have our foreign keys essentially set up the same way that we had them in SQL Server. and I'm going to go ahead and add the drop statement for the student courses as well. And again, the location is going to be before the other tables. I'm going to go back, and this is the last thing that we're going to do in this video because it's getting kind of long, and we'll take a look at how we can alter tables and make changes in the next video. But in this case, we want to go ahead and create a sequence, and we're going to be doing that for our teacher table for use in assigning IDs. And let's go ahead and let's switch over. Notice create sequence. We're going to give it what we're starting with and what we're incrementing by. It's going to be similar, but a little bit different as far as how we do this. We also don't want it to cache anything, because what Oracle will do if you don't say no cache, it essentially caches 20 values at a time. So if you don't use them all, it kind of puts holes in your numbering scheme, and that's not always ideal if you're trying to track data. So let's go ahead and let's create it first in SQL Server. And in SQL Server, come in here and going to put it right underneath the teacher, because that's kind of where it belongs. And I'm just going to go ahead and execute that, and it should create that sequence. And then if I go to Oracle, I'm going to do essentially the same thing in Oracle, copying and pasting in that and placing it after my teachers, and execute that. And at this point, we're going to stop after we look at the insert. And if we are going to start inserting data, which we will do an insert statement in the next video, we will be using the next value for dbo.teachseq. So this is going to be for the SQL Server instance, and for the Oracle instance, this is going to be teacher_seq.nextValue. So this is when we do not have an identity column defined. This is a way that we can get a sequence and use it for assigning a value into a column. More in the next video.